Well, we have all been waiting and building antennas for all kinds of stuff for many years. Put this down over a little closer. Let's see, on a PC you use the up button, right? We've been building antennas for ISS for quite a long time, and so I'm just going to go through a little bit of the what we've been doing. This is the first one to use ham radio on the ISS. This was the FGB, and on that one we actually improvised and used a telemetry antenna that was designed for the telemetry during the ascent. As this thing is launched, the Russians use this, and you can barely see it here, but there's two little antennas here. They're designed for, I think it's 172 megahertz that they do their telemetry on. And it actually works very well. So that's the first one. And the second set of antennas, which is the ones we use now all the time on ISS, here's the HF antenna, and there's three other antennas. And with all this light, it's a little hard to see, but there's three antennas right here. This is the Soyuz, the Russian service module, and there's four antennas around here, which we built, and they're all similar to the ones that we're getting ready to put on the Columbus module. Here's a picture of those. They use the same technique that we've used here, which is a center-driven element and two parasitic elements. Now on this one, we also have this big plate here, which is the ground plane, so that we have this. Actually, antenna turns out to function very, very well. But when we built this antenna, this was a cooperative effort. It was the very first real cooperative effort between the Russians, the Americans, and the Europeans. And the Europeans built this L and S band antenna. This antenna here actually works on 1.6 gig, 1.2 gig, 2 gig, and 2.4 gig. So they can use this for their television system that they have, the Russians use, for their, I don't think they've actually used that part, but it's designed to do their video signal that comes from their suit camera. And so this, in some places it's called the glisser antenna, but for ham radio use it's the LNS antenna. It also has the capability of receiving GPS frequencies, so that's a quite flexible little antenna. On there we have a diplexer which combines the two signals and sends them down the same cable. So anyhow, this is the kind of antennas we have sort of specialized in. And so now we're going to go on to the Columbus module. Now on the Columbus module, of course, is built in Europe, and it's really a European project. So the AIS Europe decided that they would negotiate with the people building the Columbus module and put some antennas on. Well, it turned out that in order to put a 2-meter antenna on the outside, it had to be so big and so rugged that they really couldn't work that out. But so what they ended up doing was building a L and S antenna. And these antennas were designed and built so that they could withstand the rigors of launch in the payload bay of the shuttle. And that is a tremendous stressful launch, because in the payload bay there's very high sound levels that are so high that they will tear things apart. So things that are built for that had to be built very rugged. In fact, the specification for this was something that I was still amazed that they were able to build anything that could withstand it. It was 48 Gs of acoustic sound level. In fact, the tests were so intense that they actually broke one of the machines used to vibrate the antennas. And of course the antennas survived, so...
the first 3 or 4 didn't.
Well, that's true.
They ripped the hell out of it.
Yeah, it was a terrible environment. In fact, we've always avoided that. We say, hey, we'll just put them on an EVA, but they didn't seem to manage that. And anyhow, they put this antenna on, and I didn't show you both antennas, but there's actually two of these antennas on the Columbus module. They have not been tested yet. They're there, but and there's a future application. This is the predicted pattern, or actually this is the measured pattern of that antenna, and this is the measured pattern for 2.4 gig. So it's a very good antenna. I mean, this project cost somewhere around $200,000, far more than we have ever spent on anything like that. So what I'm showing you here, this is not my presentation, although it's got our logos up here. This was the presentation done by the group that were proposing these antennas that we're now going to put on there. What they wanted to do was to build a system that could detect the AIS, the maritime signals that is called the Automatic Information System, or Identification System, that is put out by the ships at sea. As ships move around, they send out these signals every so often, and they're on 162 megahertz. So the idea was that they wanted to be able to receive these signals on ISS, and they're going to carry up all equipment to do that. And so they wanted to put an antenna up there. So I'm just repeating their presentation here. The idea is to detect this signal and to be able to decode these and see where these ships are. And they needed an antenna to do that. And they proposed one. And I'm not sure, I don't think I have a picture of it in here. But anyhow, that antenna is going to mount down here. And so they went through a lot of effort getting this design done. And the safety people would not approve of their antenna. They said, you know, this antenna, actually it looked like a mobile antenna from your car. So it was very stiff, and it had a big center piece that looked like a rapier from a sword. And they didn't think that was too good for the crew, so they decided that they couldn't do that. So they asked us if we would build an antenna, because we have a little reputation now that we've had 4 of them out there almost 10 years. So they decided that they would come to us, and we agreed to build this antenna. And here's where they had planned to put it. I'm just including the illustrations for you to see, but this shows where the AIS antenna would go, and this where's the AIS antenna would go. Actually, we got the best spot. We did a lot of discussing about where to put antennas, and we were just saying, look, you know, we'll build you an antenna for your project, but your payment for that is to take up one for us. So we ended up building both antennas, and we'll show you some pictures of them here. This is the routing for the cables. They have to run all the way around, and it's a long cable, but it'll still work fine. This shows how the antennas are related to the forward motion of the ISS. There, look at it here. This is a clamp that the proposed part of the project was to design a new kind of clamp that would clamp on a handrail and allow you to carry a small experiment or something like that. So we're actually qualifying that clamp as well as we are using it for our antenna. This is the first time that anyone besides NASA or the Russians have built any clamps to go outside. This is the cable diagram. Shows how long the cables will be. The AIS antenna cables is over 16 meters long. That's a long cable, but it'll still work fine. We've proven that using the Russian cable, so they're almost that long. They're about 50 feet. This is a picture of the antenna cable. designed. This small cable here, I've actually got to test a little 1-foot piece of that stuff. And all I can say is give me more of that. That is really great stuff. It's good all the way to S-band. And it's just excellent. It's very flexible. It feels like RG78, RG75, that little small PVC cable that we all use. But this stuff will withstand 200 degrees C quite easily, and it's extremely flexible, soft. But you cannot buy this on the market, because I looked at buying some of it, and they made a certain amount of it for ISS back a few years ago, and you cannot buy it anymore. It's just, but it's a great design. I don't know why they don't make it for commercial purposes, because it would be good plenum cable. But anyhow, they put a wrapping on the outside to protect it from the sun. If you look at the original S-band antennas, they use the same cables. Original Columbus module S-band antenna used the same cable, but they put no protective cover on. And I don't really understand that. Here's the predicted pattern for our antennas. It's a typical whip antenna. And we've proven this pattern work is very accurate, because that's what we've seen on the antennas on the service module. This is a picture of the AIS antenna. It's designed for 162 megahertz. And the idea was we were going to make one that would do both bands. But it turns out that it really doesn't work. To do the dual band thing we do with this antenna, they have to be harmonics of each other, or close. And so we ended up having to take off the extra tuning elements. So we just have the ground plane elements and then the center driven elements. But we use the same other components, the mounting plate and all that. So I have a question for you. What would you call, we have a gaggle of geese, right? What's a group of antennas? Is that a flock or a gaggle? Or a farm? Well, I think it's a flock myself, because they look like birds. Here we are. This is the antennas ready for shipment, all packaged up and set together. Here's a picture of the AIS antennas, and I actually brought one of them here, which I suppose we can just pass around. This is actual working antennas. It's don't jerk on it too hard, but it's pretty rugged. You can open it up if you want. Just flip it. There you go. Anyhow, this thing is designed to be able to withstand a cosmonaut, astronaut, climbing around, kicking it with their feet. It's designed to withstand all these abuses that they get when they take these things out. So if you...
Lou, that's an actual antenna that's radiating in the booth too.
I'm sorry?
That's an actual antenna that's radiating in the booth.
Oh, they're not using it, unfortunately. Here's more of the AIS antennas. We had to build 3 of each type of antennas to ship them to Europe. 1 for test purposes, 2 for flight, and we ended up building another set for the 0G trainer in Houston. So we had a whole bunch of these things built. A little closer look for those who aren't close enough to see this thing. One of the little features we had was this antenna is designed to mate actually on this mount that the Europeans designed, and also a separate mount that NASA has designed and used in the past on other experiments. So these 4 holes on the outer part fit the NASA mount, and the 2 here fit the European mount. And then this little hole right here is a tether hole, so that they can hook that on their that's a standard tether hole requirement for ISS, and that fits their tether. And here's a flock of antennas laid out on our kitchen table. And the antenna cable comes in this part of the Columbus module, and we still haven't decided exactly how what we're going to attach to this, but I'm sure we'll think of a lot of things. This is a picture of the Columbus module mock-up at S-Tech, and shows the antenna mounted on the mock-up with the clamp. And here, this is the AIS antenna mounted on this position. This thing's all turned around as to where it would be with respect to the ground, but this is the team member over there. So the plan right now is to launch this thing on STS-129, and it'll go on the ULF-3, which is the just a storage device. What's ULF stand for, Will? Do you remember? That's ultra or utilization flight storage something. But anyhow, it's just a big storage facility where they can take off a lot of stuff in the payload bag. And one of the reasons we're looking for the Ericsson radio, we're trying to get this thing together, and we were hoping that maybe we can actually take that in there and use it. But we haven't figured out exactly how we're going to do that yet. But it'll be out and be ready to use soon. It'll make a big difference in our operations because we'll be able to work directly with the crew. Right now we have to go through the Russians to get requests into the crew, so we'd like to have it so we can send direct requests up to them. I think that'll make it a lot easier. And what we're going to do for it is yet to be determined, but based on what we've done with the ones in the service module, we can think of a lot of stuff. We'll be doing experiments and school contracts and whatever with this little antenna. That's quite a sophisticated little device. It looks simple now, but it's a lot of work, I can tell you. Any questions anybody have?
What is the Ericsson radio like? What's its model?
The Ericsson radio is the first radio. It's really a police radio that we sent up on the first mission. Actually, before any of the crew were up there to work, we sent that up.
Oh, that was during the 1970s?
No, it went up in
You gotta
98.
repeat the questions. Nobody can hear the question.
Oh, he asked about what is the Ericsson radio. The Ericsson is a handheld similar to a police radio. Any other questions?
What year was that?
90. Let's see, when did the ISS first go up? It was like 2000. Thank you very much.